All right, good afternoon, everyone. I am Alex Canny with Preferred Utilities. Thank you for taking the time to join us today for our webinar series. Today we're going to be talking about fuel oil system startup. What actually happens after the system's been designed, after it's been purchased and built, once it all shows up in the field and the installer, the electrician, everybody gets a chance to install the equipment. And then one of our technicians coming out and taking a look at it. And what happens, what are some of the design considerations that will impact startup? And what are some of the differences between startup and operation? What are the things we run through? We're going to talk about training. We're going to talk about some of the lessons learned over the years. And we're going to do all of that with Don Hay, one of our veteran field project managers. I got a chance to interview him, and we hope that it is informative and entertaining for you. So we're going to go to that right now. Afterwards, we are going to have some live question and answers, and feel free to send us those questions at any time via the chat feature or via email, and we'll look forward to talking to you afterwards as well. All right, thank you very much. My name is Alex Canny. I'm a salesman with the Northeast Sales Office here at Preferred Utilities, and today I am with Don Hay, who is one of our field project managers out of New Jersey. And we're going to be going over some lessons learned and things from the field regarding fuel oil systems for boiler plants and backup power systems. So Don, how long have you been doing this for?
Almost 21 years now, Alex.
Wow, that's pretty cool. And just give us a quick background about yourself, what you did maybe before Preferred and things like that.
Well, I did a stint in the Navy, and after that I got out and did 12 years as a boiler operator at a chemical refinery until I guess you call the hard times of the economy crashed it, and we ended up closing, and that's how I ended up finding about Preferred. I never knew about Preferred or any of their equipment before I got hired by them. So everything I've learned these past 21 years has been all fresh.
Nice. So I think what we're going to do today is kind of walk through a typical project, and as we walk through that from kind of the beginning to the end as far as startup, commissioning, training, that sort of thing, we want to kind of bring out some of the lessons learned and things from the field that you can for us. And one of the first things, something that's a little bit newer, at least for me, is happens even before we step on site. Between the equipment shipping and the startup actually happening, we've noticed that as systems become more complex, things become more interconnected, a lot more integration with third-party systems and controls, communication, that it's very helpful to have some sort of documentation that helps the customer and the installer make sure that we're ready for startup service. And again, we're talking primarily about fuel oil systems here. I know you work on a lot of different systems, boiler systems, things like that. For fuel oil systems, we now do a pre-startup checklist for a lot of jobs. And that's just a document that allows the installer to go through and say, okay, do I fully have this ready for the Preferred Utilities field project manager to come and start checking it out? And what are some of the things that you see when you show up on site for the first time at a new project, some of the things that usually get missed?
Well, as far as things getting missed, sometimes it would be the flow switch being installed in the wrong direction. That's a big problem. We use a motorized ball valve for diversion of fuel, like say from a day tank to a storage tank for our suction integrity system, and they don't read the manuals and just pipe it like they think it's supposed to be piped, and come to find out that they usually pipe it to the wrong port. So to start off just stepping on site, walking the system with the contractor is the best medicine to be able to confirm whether or not they are actually ready.
Yeah, and I've noticed that as well. And it's not necessarily the fault of the installer. A lot of our equipment and a lot of fuel oil equipment in general is not necessarily intuitive if the pipe fitter or electrician or installer is used to doing other sort of hydraulic systems and things like that. You know, a lot of things that may be normally open on another system will be normally closed on ours. So it's not necessarily saying that, you know, they're not doing what they need to as far as a typical system, but fuel oil systems are kind of a strange animal, and we try to reflect that in a lot of our documentation, whether it's our submittals or O&Ms, make them very detailed so that that sort of thing can be provided for. And you mentioned something walking through the system, and this is something we've seen a lot more of on larger projects, where if we have a significantly sized fuel oil system, even before startup, it's helpful for the local sales rep or field project manager to walk through the system maybe after the equipment is shipped, so that everyone's on the same page of where it gets installed. Because there can be times where, especially if you have a requirement for things like socket welded piping, it can be very difficult to go back and swap valves around and things like that. So on larger projects, we'll build that time in from the beginning, and it can be very helpful to head those problems off before they become significant. So one of the questions here, Don, and it's something I get a lot, and people see it kind of sometimes from a liability perspective. In your opinion, is it okay for the customer to go ahead and power our controls up before a field project manager is on site? Is that something that you would encourage or discourage?
I would discourage it for the simple fact that they have licensed electricians that do the wiring. But if they don't follow our wiring diagram specifically, correct size gauges of wires, use of separating intrinsically safe wiring from AC voltage, these things could present issues if they were to just nonchalantly just power the system up before anybody's checked things out, because you got to make sure that all the terminations are complete and they're in the right locations, and that all the other safety precautions are met.
Absolutely. Now, moving past the pre-startup and kind of the walkthrough and things like that, I know for myself, I do quite a few startups here in New England, and one of the most valuable things for me, and I'd like you to comment on this, if I am going into a job that I haven't been to the site before necessarily, it's either it's a brand new building or a brand new install, retrofit, one of the most valuable things for me is, if it hasn't been done already, just to walk off the entire system, to physically see all the components, whether it's where they've placed different control panels, valves, things like that, anything that's remote. And I had one situation where it really came in valuable from a safety perspective, because the system itself looked fine. In fact, it was actually a retrofit to an existing system, which made a walkthrough seem maybe less valuable in that case because it had been running for years before. What I didn't realize was that downstream of everything, all of the relief valves and return lines and all of that actually were deadheaded down at the end of the system. And we weren't aware of that until I walked down and saw something that happened to be capped off. And it wasn't even necessarily a manual valve. So in that situation, had I tried to start that up or test relief valves or something like that, we could have had a high pressure problem, could have led to a leak or something maybe even more serious. So in your opinion, is looking at walking through the entire system, looking at all the components, valuable as far as one of the first things that you do?
That's probably the most important thing you can have done, other than the pre-startup form, having the customer fill that out, is to walk with the customer through the whole system from where the storage tank is or where the pump set is, and walk through to make sure that any field devices are installed correctly and in the most ideal location to be used properly, making sure day tanks are installed properly with the proper flow directions for, like, a manifold, if you're using a manifold for that. All these things make it that much easier, so when you're ready to start filling a day tank or starting up a boiler loop or even a manifold for a multiple generator system, making sure that everything is piped correctly and then installed correctly makes the job that much easier.
That's great. Absolutely. And it really doesn't take that much time. And I know for myself, it when I walk off the system, if I'm troubleshooting it later, that helps to bring a lot of things to mind that could be culprits. Now, what are some of the things that you're specifically looking for on the electrical side? I know for myself, typically I start by looking at piping, valves, things like that. They're going to cause, say, overpressure or cause the fuel to not go where it needs to go. On the electrical side, what are the kind of things that you look for first when you come to a site? Do you start by looking at opening up the panel and seeing the power connection? What are the kind of things you begin with?
I would start at the control panel, especially the master panel if it's a multiple panel system. And I would look to make sure that you have your low voltage and your AC wiring separate, so that there's no noise created. Making sure that the low voltage wiring is not run in the same conduit with AC, that's a big no-no. Making sure that the power is terminated properly. Making sure that you don't see any bad terminations for wiring, and first off, making a quick glance across a terminal of, like, say, an FSC or even a terminal strip in a PLC type panel. If you look at the wiring diagram and look, you can pretty much spot pretty quickly if you got wires landed in the right places. And then you follow back the conduits back to where they did the installation, like, say, for a containment pipe leak switch. All right, we use a PLS1 or an RBS switch, which is a very unique device, is that it can be mounted in a normally open position or a normally closed position. Our standard systems use normally closed, so you have to make sure that they installed it properly so that when it's wired up and it turns on, it's not reading incorrectly. It can be corrected in the field, but that's just one of the quick things I look at. I look at, like I said earlier, flow switches, making sure a flow switch is in the right direction so it works properly. Any motorized ball valves, making sure that they're installed correctly, that the wiring is complete. You've got level switches on the day tanks, making sure they're installed correctly. Wire floats or any type of other level sensing devices on a storage tank, making sure that that's installed correctly, making sure the wiring's complete, that the low voltage wiring for that is not running in AC conduit.
Excellent. And one of the things you mentioned there, I'd like to spend just a minute on, because I think it's something that I've seen on jobs be a bit of a hang-up, and it's one of the things that I think is also more unique to fuel oil and to preferred utilities as far as our design philosophy. And that's what you mentioned about our RBS switch, normally open versus normally closed. A couple of things here. Number one, on most of our modern systems, we're going to be using normally closed on these switches, and for a lot of different field devices, if it's an on-off device, we're going to see it as normally closed. I look at that as an advantage, because that tells me not only the state of the switch, but also that the wiring is correct. So if I have a normally open field switch, that makes me think I should probably check the wiring as well, maybe ring it out on both ends to make sure that's correct. But with normally closed, I know that the circuit is completed, right? So that tells me that not only that if it's a leak switch, that I'm not in leak alarm and my wiring is whole, but further than that, I've noticed that there can be a lot of confusion about the term normal. And we see that especially on day tank level switches. For instance, I had a project where we had to retrofit level switches into it was actually a sub-base tank or a belly tank on a generator enclosure. And it took longer than probably both parties would care to admit to realize that we were both saying normally open or normally closed, but we actually meant different things about normal. So for our equipment, Don, it seems that almost across the board, for instance, if we're shipping a day tank with a level sensor in it, our normal quote-unquote condition is going to be normally closed on all level switches on a dry tank. Is that correct?
That is correct, and it clearly states it on any type of drawings.
Right, exactly. And so sometimes, and this is just something to be aware of, especially when reviewing submittals and things like this for engineers, that sometimes people interpret normal as a full tank. Or in the case of my experience, they'll interpret normal as the tank 75% full. So we have, if we are interpreting that as normally closed, they may see that as the lower two switches, low level and pump on, being floating and closed, and the upper switches, pump off and high level alarm, as being hanging, but still closed electrically. So it's something to look for, that even though we may be describing it in the same way, we may be interpreting the word normal differently depending on the equipment, depending on the design. So after we've looked at all the different electrical components, we've taken a look at the panel, we've made sure especially that our low voltage and high voltage runs are separated. And Don, what are some of the things you've seen in the field with not separating low and high voltage? I know for myself, I've seen cases where if we have a low voltage leak sensor, say, our model HDA2C, I've seen cases where if we're running that too close to a motor starter, that when the pumps come on, we'll get a blip and we'll see like a false leak alarm momentarily, things like that. And I know you probably see a lot more of these sort of things on the boiler control side. But what are some of the things you've seen in the field, problems with not separating those voltages?
Basically, it's stray voltage. Low voltage, even though it's shielded wiring, if it's in the same conduit with AC wiring, is you run the risk of giving an incorrect signal across that intrinsically safe wire. I mean, you could get a bad level reading, or like you just said, on a leak switch, you could get blips on that to where it says water or oil or something. There are proper procedures in both the NFPA codes for electrical and also on our drawings that specifically states that you're supposed to separate the two, AC and DC, so as to not create any noise.
Right, exactly. And that's very important. Thankfully, at least on most fuel systems, we don't have variable speed drives, so that helps a little bit. Get rid of some of the gremlins. One of the things that I also want to talk about, and this is a function of where our controls are now versus where they were in the past, as far as complexity, functionality. One of the things that's most helpful for me, I do a lot of startups, but it's not what I necessarily do every day, quite as often as you do. And I think it's also helpful for people that are at a facility that aren't necessarily interacting with our fuel oil system every day, but when there's an alarm or something that needs to be troubleshooted, they are able to pull up information very quickly. And that's our touchscreen interface, and specifically on that, our VYO screen. So this is one of the most helpful things for me on our equipment is being able to pull up the VYO screen in our controls and actually seeing now all of the voltages, whether inputs are on or off, powered, unpowered, what our analog ins and analog outs are doing. And it's changed it from kind of hunting around with a handheld meter to now being able to see kind of an overview. And it works very well with our documentation. Is that something that you use a lot when starting up and troubleshooting?
I'm kind of old school about that. I like that. I like a wiring diagram with a meter, but I do, since we have now gotten more into touchscreens and operator interface panels, the IO screen is a very valuable tool to verify that, say, a flow switch is in a correct state, or that a leak switch is in a correct state, or the analog that, what are you reading voltage wise? Is it showing you 20 milliamps if the tank's 100% full, but in actuality the tank's empty? That's a good quick reference point instead of having to go physically look, or you can do everything right there at the panel.
And along those lines, Don, what are some of the biggest changes that you've seen? I mean, when I look at a system that's 20 years old, for instance, the pumps look pretty similar, right? The skid itself isn't that different, but it's the controls, right? The electronics are what's moving most quickly in a lot of these systems. What are some of the biggest changes and impacts that you've seen over the last couple of decades with fuel oil systems?
Are you saying I'm old?
You have good experience.
Okay, there you go. Well, I had the opportunity when I first got in, started working for Preferred, I had the opportunity to see a very wide gamut, or actually see the growing progression of programmable logic controllers. I've had the opportunity to see several panels that are relay logic only. That was like the first panels that were being used to automatically control fuel oil pumps. Move forward, they started out with this magical thing called a Roadrunner PLC, which was basically a circuit board with digital relays in it. Then we migrated from there to the first programmable logic controllers, which were modular. You had the Koyos from GE Fanuc. You had you had the Koyos, you had the GE Fanucs, and various other Allen Bradley. Everybody's gotten into the programmable logic controlling thing. Preferred also got into the business of making their own controllers, where when I first started here, we were always using either GE or Koyo, and then we came up with the PWC, which was a major step forward in simplifying our control package, but make it very versatile, which to this day, it's still a very versatile piece of equipment. And then we went from there, we progressed to our FSC controller, which, the thing I like the best about that is you do just local wiring on the panel, and everything else is communications across the NodeNet communications field. So that's what I've seen over the past 20 years with Preferred.
And I think one of the interesting things about Preferred is that we're not necessarily doing things with controls that other companies can't do. I think one of the things that we're doing is we're bringing a lot of experience to the table to do it right the first time, but also on the product development side, whether it's our PWC or now our FSC platform, we are building dedicated systems based on that experience that are designed tailor-made for these fuel oil applications. Whereas, we used to, and a lot of the market out there is filled with generic PLCs that are kind of adapted to the fuel oil market, right? So I know for myself, it's been a pleasure to use a lot of the newer products that are tailor-made for these applications, and the FSC is the one that we have right now. Is doing very well. So going back to kind of the startup sequence here, once we've taken a look at where the fuel is going as far as valving, piping, that sort of thing, we've taken a look at the electrical. Now you're starting to dig into maybe turning over pumps, doing some testing. Where do you like to start as far as function testing the system, kind of getting into the meat of the startup?
Well, when you're to the point where you can power up the panel, the way I like to start it is I look at the alarm screen and I go through, and if I have any alarms, address each one of those alarms either in the field or locally for the wiring to make sure that it is correct or incorrect, and make the corrections so that once you're ready to start, you have a totally clear alarm screen. And then you can start doing like verifying that your oil is reading correct level on the storage tank. Because if you don't have a correct level reading there, then you're going to get everything messed up when you start pushing fuel around. Then you start with whatever it might be, whether it be a boiler loop, then you've got to institute or initiate a call for operation and verify. But before you can do that, you need to make sure the pumps are rotating correctly, verify the voltage coming in, that it matches the data plate on the motors, verify that the amperage is correct, that you're not overamping, that the overloads are set properly. These are initial steps that you need to take before you actually start pushing fuel out.
Right, and that brings me to something that we're seeing a lot of here in the Boston area. And I don't know if this is somewhat unique to maybe generator systems, but a lot of times before we're even allowed to put fuel into the tank, so whether it's the main tank or the day tanks, we now have to have at minimum basically leak detection fully tested and maybe observed by the local authority. Do you see a lot of that? Because I know you travel around the country a lot, Don. Do you see a lot of that kind of that staged startup where we'll have to start up the main tank system in order to get approval to fill the main tank and then move on to the rest?
Over the past 20 years, it's been sporadic on seeing things where the fire department or any type of local community is responsible to allow fuel to be stored in certain areas. They have to pass their certifications and all. Boston has just really started that, or it's been standard there. A lot of other places, not so much.
Okay, so it's not necessarily something that you're seeing across the board. And that's one of the interesting things about this is that it is quite regional. And I'm sure you see that being on the road a bit, that even one state to the next or one city to the next can be very different as far as what their requirements are. And speaking of generator systems versus boiler plants, in your experience, has there been a trend? I mean, it seems to me here in the Northeast that we're doing a lot more generator systems now than we used to, whereas it used to be more of a mix of boiler plants and generators. Is that something that you're seeing as well?
It's always been the past 20 years that I've been working here that it's been very heavy on the generator systems, because that was the advent of the .com era, when everybody was getting online, and then all the data centers. I mean, a lot of data breaches made it point that a lot of big corporations needed to have off-site storage, so they needed to have backup emergency generator services to keep the power running. So I see an awful lot of the generator systems that are more so than boiler systems.
So, Don, as you're working through the startup and getting towards the end, you're working through all the different alarms that are present. And I know for myself, it's rare that you start up a system that doesn't have, several alarms on it. What are sort of the things, once you've knocked out a lot of the alarms, what are the sort of things that you're looking for as wrap up, kind of the end of the startup, maybe moving into commissioning mode, that sort of thing?
Verifying that I'm getting a call for operation for empty tanks if it happens to be a brand new system and they're waiting for fuel. So I should only see those indicators or alarms saying I have a low level tank and it's calling for fuel and the pump's faulted. That verifies that that part of the logic in the control system is working. And that's where I can then begin to isolate and take it one tank at a time. You never want to do all of them at the same time because you put an undue stress on the system unnecessarily when you want to verify that each one of the day tanks works properly in all their different functions.
Well, and I mean, if you have 4 or 5 day tanks, it can be hard to know if everything doesn't go perfectly, which startup is the time you want to find that out. If multiple things are happening at once, it can be hard to really isolate those variables at that point. So yeah, it's a really good point, trying to do it step by step so that if something does go wrong, you immediately know what the culprit is.
The biggest thing for that would be taking it one tank at a time is that you verify that you are going to the correct tank. If your system says tank 1 is filling up, but all of a sudden you see tank 3's level going up, then you know that somehow the wiring got messed up.
And that may not be obvious from just a control side, which is why it's important if you're in the same area to be monitoring like manual level gauges, things like that, maybe an access port of some kind. But if you're not in that area, to be in communication with somebody via radio or cell phone or something like that, that can verify that, the tank is filling, but also something like high level. I know for myself, there have been situations where if we're testing a high level switch, I have to ask myself the question, what if this doesn't work? We're testing it for a reason, right? So if I'm just looking at a control screen, I might not be able to see that in time, but being able to see it in person or have somebody observe it.
A quick note about a recent job that I did in Kentucky. There were 3 day tanks and everything checked out as far as the flow manifolds with the solenoid valves and all for each one of the individual tanks. It wasn't until we actually started putting oil into the day tanks was that we found out that the continuous level sensors that were being used for indication of a actual digital gallon level, we realized that they were not wired properly by the electrician because we were filling day tank 1, but it was actually showing as being day tank 3. It ended up being that all we had to do was switch the wiring in the control panel to make it work properly. But that's another importance for taking it one tank at a time.
Absolutely. And what are you seeing as far as commissioning requirements? So once the system is started up and tested and you have a good idea of how it's performing, at least from your own perspective, a lot of times then the owner or commissioning agent is going to require that to be demonstrated, right? And I know sometimes the commissioning sequence can be very, very detailed down to confirming the color of the paint on a day tank, the names of different alarms, things like that. What have you seen over the years as far as commissioning requirements? Have they gotten more stringent, more complex?
It varies from job to job. I mean, I've probably done 2/3 of my startups over these past 20 years where it has not required a commissioning agent or a third party to verify the system for the owner. I mean, basically a commissioning agent is there just for the owner to prove that he's getting what he paid for. But the ones that I have done that have actual commissioning agents, they usually take all their documentation right out of the spec, and that's where they put together their test parameters. They do sometimes ask for our input of how are you going to do this kind of test, or even when we're actually doing the test, that they're actually looking for input from us on how it's best to do that certain test that they need to prove.
So the test obviously needs to happen, but it may be a test, maybe a case where we can help guide them as far as how to perform the test.
Yes.
Excellent. So after commissioning, usually what we're going to see is something along the lines of owner training. And for a small job, we may do startup commissioning, owner training all in one day. For larger projects, it may be scheduled out at a later date, once the building is turned over. I am seeing a lot more requirements for documentation ahead of time for owner training, putting together an outline or a syllabus, something like that. And then after the fact documentation. What are you seeing as far as let's take a larger, more complex job, not necessarily a single pump set startup, walk in, walk out, but for the larger projects, what are you seeing for owner training?
Going back to my job that I did a couple of months ago in Kentucky, this was a medium system. It had 3 day tanks, it had a pump set, and it had a day tank control panel. So it was a 2 FSC node system. Once I finished the startup, owner training was requested and scheduled. The contractor that had us out there that did the installation provided a videoer to do a videotape of my actual training to the operators at the hospital. And I did a standard training class highlighting all the functions and all the important points in the system, and then also giving them detailed operation on how to navigate the screens, how to troubleshoot, being able to identify certain components inside a control panel, and understanding that this is a wire float, this is where you're getting your level from, this is a leak sensor, this is where leak sensors come from, and this is where you get to see where that leak sensor displays. The same thing with level on the day tanks. This is the screen you go to for that. If you have a problem with that, you can actually go in and see through the IO screen, you can actually go in and see the milliamps on what you're actually getting as far as a level, and you can pretty much verify that, hey, it's reading correctly or it's not reading correctly through that.
That makes sense. And you mentioned something in passing there, Don, nodes. And I just want to real briefly, for people who may not be familiar with this, one of the advancements that we've been working on is peer-to-peer communication through different parts of the system. And it's something that I'm seeing in more and more specifications, whether it's listed as like an Allen Bradley system or something like this. But we developed our FSC controller in-house as a dedicated controller to be able to have this capability. And just a brief summary, Don, how have you seen that implemented in the field as far as communication between, say, the pump set, the day tank, things like that? What are the advantages that you've seen?
The beautiful thing about the NodeNet communications and the FSC is that you're making it a modular system. You have a control package that's, say, the pump set. That's your master panel or your node 0. That's always the big boy, the one that handles all the stuff. Then you have individual nodes based upon, like, say, you have a day tank. You have 3 day tanks. You have 3 separate control boxes that each one has their own dedicated node number. So now the beauty of having these is all 4 of those nodes are connected by 2 shielded cables. That is NodeNet A and NodeNet B, which is the communications between the 4 different controllers. Old style pump sets with a standard PLC, every wire that came from the day tank went right back to that control panel, and you had all those wires running through the building, up, down, and around, and all that stuff. Now with the NodeNet communications, all the field devices on each one of the day tanks go to that specific node, and then you just have 2 little wires that go back to control panel, so it knows when to supply oil to it. So you cut down on the amount of AWG or stranded wire wiring tremendously.
And from a user perspective, I know it's great for people like myself and you that are very well versed in fuel oil systems and our fuel oil systems, but some of the feedback I've been getting from people in the field is very good as well, because a lot of facilities engineers are spread a little more thin maybe than they used to be, and systems are getting more and more complex, so it's maybe not as much of an opportunity for every one of them to be an expert in every system that they manage. And so being able to go to any point in the system and see exactly what's happening is quite a step up over the old, I'm on a walkie-talkie and I got a guy with a flashlight looking into an access port on a day tank, hoping that the day tank is filling. Whereas now I can see, okay, what's my inlet manifold doing? What are my levels doing throughout the system? And be able to visualize that very quickly rather than looking at a relay panel where a bunch of lights are on, a bunch of lights are off. What does that mean? The alarm's blaring.
That's excellent.
Yeah, from an operational perspective, I think it's very valuable as well. That's great. So as far as training, what are some of the things that you really try to bring out on the operational and the emergency side with the owner that are key to remember? Because as I just said, when the alarm's going off, it's very hard to interpret all of the information that's being given, and as systems get more complex, we're being given more information. So how would you frame that to the owner? Let's say the bell's ringing, right? And they're in a situation where they need this to run. Walk them through, and I understand you're not going to be able to cover every situation, but kind of walk them through what are the things that we would look for.
Well, primarily, if you get an alarm, 9 times out of 10, it's going to be transmitted to a BMS system. So they're going to get a visual of what that alarm is right away. But if they're not, and they're in the field, they go to the panel and they look at the alarm ribbon that's at the bottom of all our screens and see what the current alarm or alarms are going off. And then they can make their determination on what needs to be done from that. So important with training is to have them understand how to navigate the screen and know what they're looking at when they go to certain screens. Also, from a preferred standpoint, all of our pump set panels are designed in such as if that PLC fails, you still have manual control of those pumps. So you can get a level or a day tank filled by putting the pump in hand.
That's a really good point, Don. And we see this as a basic industry standard for advanced controls for backup power and mission critical applications, where we can get some pushback on some of the newer systems, especially for facilities or engineers that are used to using legacy systems where, okay, this has a computer in it now, right? And I know computers don't always work exactly the way we want them to. But that's a really good point that a system and all of our systems have, and other systems should have, some way to bypass in manual mode all of the wonderful fancy electronics. If there's a program issue, gets hit by lightning or whatever, and to manually turn those motor starters on. But that being said, especially if we have a multi-day tank system, it's very important then, if we're running this in manual, what are some of the considerations that we want to have? If we have to, let's say, the PLC or the controller's down, we've now made the decision to turn pump 1 on in hand or on manual on. What do we need to make sure of at that point?
Well, it depends on if it's a single day tank or a multiple day tank. If it's multiple, then 99% of the time there's going to be a control manifold to each one of the day tanks. With the PLC being down, that means there's no power to the solenoid valves that are keeping that closed. So you're hoping that the system was designed with a bypass line on it. So that would require 2 people to fill a day tank. 1 person running the pump in hand at the pump set, and 1 person monitoring the level in the day tank and controlling the bypass line around the fill manifold to ensure that you fill the tank up and can isolate it once it's done.
Exactly. And I will say, even though that does sound a bit complex, it's certainly better than having to lug fuel up in 5-gallon buckets when the elevators are down. So
absolutely,
it's kind of the best of a bad situation there. All right, so we've run through the training. I will say just one more note on training. As far as maintenance items, one of the things I try to really communicate is that, especially for a system where maybe they don't have as much information coming to a control command center, that, and even if they do, to lay eyes on the system itself periodically, whether it's the day tanks, the transfer pump set, things like that. But as far as wear items and maintenance items that need to be changed out or greased or anything like that, there's really not a lot on most of our systems. Is that correct?
It is. A good rule of thumb for most preventative maintenance is to, like you said, visualize the system on a periodic basis. It doesn't really have to be daily, because most of these systems are going to sit until they either do a test or there's a true emergency. So on an annual basis or a semi-annual or a quarterly basis, the customer needs to take a look at specific things, making sure there's power to the panel and that everything seems to be reading correctly. Taking a look at the strainers, whether the system has a simplex strainer or a duplex strainer. You need to open that up periodically to verify that there's no debris in there, because a lot of times if it's a new installation, you could have slag from construction or welding that could get clogged up, or you could have something that is trashing the system, maybe a bad delivery of oil. And that's what the whole purpose of those strainers are, is to keep that stuff out of this pure fuel that the generators need. They don't like dirty fuel whatsoever. Most of your pumps nowadays are sealed, so there's no need to do any greasing or anything of them. Same thing with motors. Most of the motors are sealed bearings, so you don't have to do that. But laying eyes on it to verify that everything seems to be rotating properly and that there's no like leaks or anything. Verifying that any type of emergency valves, like a Fireomatic valve that is designed to shut off the oil coming from the tank in case of a fire, making sure it's taut and that it's open and ready for service. That's just some of the things that could be done in like a quarterly or a semi-annually type test, or monthly even.
Absolutely. Yeah, and that strainer is a big one, because we have presentations on fuel oil quality and fuel quality, how it impacts system design and things like that, and which you can check out on our YouTube channel and on our website. And a lot of the time the question comes down to, how do we determine the quality of the fuel oil in my system? And I like to tell people that one of the best ways is to look in the strainer, because it tells you a couple of things. Number one, it's gonna be pulling things out of the fuel that you may not see on your own. And number two, it's telling you what's in the fuel that's being seen by the transfer pump set. So if you look into your main tank, you're seeing the fuel at the top of the tank, or if you're sampling, what part of the tank are you sampling from? A great way to tell what kind of fuel is going to your day tank, take a look in the strainer, because that's the fuel that's going to your day tank. So it can be a great place to look for that. So wrapping this up here, I know typically one of the last steps in this sort of process of starting up a new fuel oil system for mission critical application is going to be documentation. So can you walk me through some of the things that I know we have a checklist of things that we generally provide to a customer. What are some of the things that you see in the field that an owner or our customer are going to ask for as far as documentation after we're all done?
Yeah, that's a good question. Most of the systems that I've been on as far as startup, our customer needs a documented startup to prove that the system has been completed and tested, and we would then provide that to them so they can get that marked off their required actions, so that they can get paid for one thing. The job's not done until the paperwork's done, and that's one of the most important things. And our documentations, real quick, that we use are custom to every system. There's not a vanilla form that is the same for everything. Everything's unique, but it will document electrical, plumbing, and also sequences of operation and any type of alarm checks. All that would be in the documentation that we would turn over to the customer.
Oh, that's great. So I think that kind of gives people an idea, people that don't necessarily get to go into the field and start up these systems a lot, gives them kind of an idea of the things that we're looking for, the things that we run into. Are there any other general observations that you would have, Don, whether you're talking to an install contractor or maybe a consulting engineer earlier in the design process, some things that you see that maybe could be headed off, some trends that you see, or some issues, anything that you'd like to speak to generally?
Well, sure, there are things that are repetitive that we're always running into in the field. My recommendation for anybody, whether it be a design engineer or an installer or a customer, is if you're not sure about something, give Preferred a call. Preferred has a dedicated technical support section, which will be more than happy they have hands-on of any of the documentation for your equipment. If you're not sure about how a wire float gets assembled and installed and calibrated, I mean, that's one of the things that we see a problem one time. They didn't read the documentation that comes with it to know how far they have to space the float off the end of the stop of the wire. So don't hesitate to give us a call for any questions so that you have no doubt about it.
Absolutely. And I would encourage people on the engineering side as well. We are more than happy to help with any questions that you have regarding fuel oil design. One of the reasons that we do things like this is that we try to bring the knowledge that we have from real world experience in the field, dealing with the equipment itself, whether it's existing equipment, brand new cutting edge designs, and we try to bring that to bear in the design process, all the way through submittal, installation, commissioning, all of that. So if you ever have any questions, whether it's a 30,000-foot question, how would we go about doing the system, or should this specific switch be normally open or normally closed, and what are the implications? Feel free to reach out to us anytime, and we'll put you in touch with somebody that has the answer if we don't, for sure. So, Don, thank you for your time.
Alex, I don't mean to interrupt you, but there is one very important thing that I think would be very good for design engineers and our customers. I've seen this for the entire time I've worked for Preferred, is you have fitters that usually get the contract for the pump set. Then you usually have the electricians that get the contract for the generators, which usually comes with the day tank. Unfortunately, the two of them don't talk together, so when we get on site, there is somebody else's controls on the day tank for level control that don't interface with our Preferred panel, so now everybody has to get together and figure it out. If they talked about this at the initial stage, then those questions and issues could be solved before anybody starts up a system.
That's a really great point, Don, and I think it's so important because it's something we're seeing a lot more of. I know different parts of the country, different disciplines. If you're out west, maybe it's more plumbing engineers. Here in the east, it's HVAC or mechanicals. But that transition of the electrical engineers now handling a lot of the things that happen at the generator, whether it's an enclosure that includes the day tank or a sub-base tank, it's usually in a dotted little box on the drawing provided by electrical. And now that scope is split up, having that communication between the two is so vitally important. Don, I had one job where it was as simple as coordinating the level switches in the sub-base tank. And we can have a $100,000 fuel oil system. It's all running off the $50 level switch in the belly tank, right? The on and the off, that's what it's all about, right? And it stopped a major project at a critical facility for weeks because determining, can we retrofit different sensors onto here? Are they normally open? Are they normally closed? How do they get integrated and that sort of thing? So, it's really the nail in the horseshoe, that causes the horseshoe to fall off, and then you lose the horseshoe, you lose the horse, you lose the horse, you lose the war, right? So sometimes these small details, and this is one of them, and it's getting that communication as early on in the design process as possible. One of the limitations, I know you've probably seen this as well, that relying just on maybe submittal material, like from the generator rep, can be problematic. Sometimes it's not easy to know exactly what's going on inside the tanks that are being provided. So drilling down and finding out the specifics on what is integrated with the controls, and maybe even making a provision for those control devices, such as level sensors and leak detection on the generator, sub-base tank or day tank, being provided by the same person that's doing the pump set controls can be very valuable as well, so that that they're going to talk to each other on day one.
Yep,
And that's a really good point, Don, and I'm glad you brought that up. Well, thank you very much for your time, Don, and we're going to be having some question and answers live here in a minute. Hopefully everyone can join us, and we'll speak with you soon. Thank you very much.
Great. Thanks for your time.
All right, welcome everyone back to the question and answers part of this webinar. We really appreciate you being here. Alex, I see you're online. Thank you very much. Let's see.
I'm online with you.
Alex and David? Okay, great. David, I think your microphone might be somewhat muted. Also, I believe Don Hay just texted me and he said he's off the job site now, so we're just trying to get him on. So,
great.
which we should
I'm
have
here.
in a, oh, Don.
Hello. I snuck in.
Hey, thanks, Don. It's good to have you. All right, let's just start rolling through some of these questions. David Oaf, I believe, has some other questions that some people asked. So let's just start with these questions. Let me see. Questions. So first question is, I guess, more of a question that was at the beginning of the webinar. It's like, how did you discover the deadhead, Alex? I believe that was on a job you were on before. You talked about you walked over and just saw the deadhead.
That was a story I used to illustrate the importance of walking off the system. So I basically just took a look at the return lines, knowing that if the relief valves are going into the return line, in most systems, they're going to go all the way back to the main tank. In this case, as I followed the return line back towards the main tank, it didn't actually make it there. I think on this job, the main tanks were located outside of the building, and before the return line got all the way back to the wall, the building envelope, they were just capped off. And that presents a real problem because now we have no way to bleed off fuel on an overpressure. So that was really just as simple as looking at the piping. Now there are cases where that are quite rare where you're going to have maybe blockage in the return line. I did have one case. It's the only time I've seen it happen where a relief valve just simply didn't open when it was tested. At least didn't open right away. It eventually opened, but we had pump set that was rated for maybe 50 or 100 psi, and we did probably 200 psi for about half a second. That was pretty scary. So yeah, it's just in a lot of cases just as simple as looking at the entire system, seeing where valves are placed, seeing where piping runs to, that sort of thing.
Absolutely. Don, any comments on that?
No, I think Alex covered it.
Great. So next question, and I want to tell us for everyone that's here right now, is the slides. If you'd like to be sent the slides via like a PDF, I can send those to you. If you want to personal or email Alex or myself, you can go ahead and just ask for the slides. I can send those out to you. The video portion of this will be uploaded to our website and also on YouTube, so you can search the title of the webinar, Fuel Design Startup Considerations, and that will be up on our YouTube channel, so you can watch as many times you want, share with someone. It's totally fine. The next question is, Node A and Node B is a proprietary communication protocol. Is Node A and Node B a proprietary communications protocol or BACnet, LON, Modbus, etc.? Also, is Node B a backup of Node A? So I guess he's talking about the FSC.
Right. Don, you want me to take this one?
Well, all I can say is Node B is definitely backup to Node A, but
Right.
you can take it from there, Alex.
Yeah, so as far as redundancy, Node B and Node A are both operating simultaneously. If we lose, let's say we have an installation where the customer chooses to run Node A and Node B up different sides of the building, for instance, and on one side of the building, we lose communication, say a forklift hits that line. In that case, we will show an error for Node B loss, a Node Net B loss, but the A side will continue to communicate. So it's really redundant, constant communication in two loops throughout the entire system. And as far as the communication protocol, my understanding is it is a modified Modbus protocol. So it's built on the Modbus platform, but it's modified with some proprietary elements and tailored to the fuel application for our FSC controllers.
Okay.
I'd like to just add one little thing to that. This NodeNet communications is just between the individual FSCs. It doesn't transmit to somebody else's BMS system or to the internet or anything like that. It's just between our controllers.
Yeah, and that's something that's important. The last webinar that we did, Michael, was it the last one or the one before we did on security?
I think it's the one before.
Yeah, and I know Luke Amory brought up a lot of those topics. And as communications become more and more prevalent, obviously we want to prevent any sort of compromise because these systems are life safety, they're critical systems. And so, like Don said, our standard application is a completely closed communication circuit. Now, we have done jobs in the past where we have run communication between nodes over hardened networks at like a hospital or a data center where these are extremely well managed networks that are, nearly impossible to hack into and things like that. So we have done systems like that where they're running over the actual network in the building. We've also done modified systems where one system we actually used a run of fiber optic at the facility to handle communications with some of the equipment at an upper level, which was an interesting application. So there is some flexibility, but obviously the key is always to make sure this is a very secure communication system.
Great. Kind of a more specific question. We have a few really specific questions. So I will be sending these more specific questions to the presenters themselves, and they'll be getting back to you with more lengthy answers probably. So the first one is someone's asking about if we can show a typical P&ID drawing of a fuel oil system and how you would color code and draw to ensure that all sequences are tested individually for a commissioning report. And that seems to be more of an in-depth question. I don't know if you want to just speak to that,
well,
Alex.
I say it highlights one of the things that we try to emphasize with consulting engineers and with owners and things like that, where custom design is really key. And we go over this in one of our previous webinars on fuel oil system design, where we're more than happy to assist with working up a PNID or something like that, or the method of how we would categorize different things, make sure we cover it in commissioning. But there really is no one size fits all. There are a lot of one size fits all systems out there. Many of them have been retrofitted over the years with various alarms and things to try to make them more functional. But as far as a typical, that's really hard. It's really hard to come up with a typical system because every system is going to be a little bit different. So if there's a specific application or something, a starting point, we'd be more than happy to help with that. And I look forward to following up with that person in the future.
Great.
Alex, this is Dave Oaf. I have a library of AutoCAD drawings that have fuel oil schematics in them. So the library includes, above ground storage tanks, underground storage tanks, one generator, two generators and a boiler. So each time I make a new drawing, it just kind of goes into this library with a generic name. So if the person will give me a few details about what the equipment is in their system, I'll either have the drawing already or I can quickly put one together.
Excellent. Thank you, David. The next one is, what sensoring and monitoring instrumentation would you recommend for fuel oil systems to perform real-time predictive maintenance? And I know we talked about maintenance in the webinar, but Don or Alex or David, do you want to speak on that?
Don't everybody jump at once.
Well, I don't know of anything that we have that has predictive maintenance schedules. I mean, there's recommendations in most O&M manuals we send out about specific parts and pieces of the equipment.
Yeah, and as far as predictive maintenance, I mean, we mentioned in the webinar that as far as like wear items and things like that, there isn't a lot on a typical fuel oil system. What I would say, and I know we've explored some things like with doing the work that we have with our cloud monitoring, more so on the boiler side. But as far as predictive, the things I would be looking at if I was to put together a protocol like that would be testing things, operational things like level floats and day tanks. And so things that would typically be done manually, like you would, however often you would run the level up in the day tank to the high point, make sure that float isn't stuck or hanging dry, and then use a return pump to run the level back down. Things like a suction line integrity test. So it's more on the side of making sure that all those operational points and alarms are still functional periodically.
Absolutely. Anything else?
One thing I'd like to add to that real quick. I just got back from doing a upgrade of a 22-year-old panel with a new FSC control panel for a small communications company. And one of the new programming features that was in the standard panel is they have a top-off feature, so that if your day tank is not at the pump-off contact or where the normal fill stop is, you can actually push that button and it will top it off for you.
Wow, that's cool.
Yeah, we get a lot of requests for that feature as a custom option for a while, and that's because many times if you do a generator test, number one, it doesn't always test your fuel system every time. So unless you're on a lot of load and you're pulling a lot of fuel out of a small tank, it may not actually cycle the fuel in the day tanks. But let's say the day tank is completely full and you're below your pump off and you never quite make it down to pump on, or you do, but it's halfway through the test. This allows you to have the maximum amount of fuel in your day tank without actually being in high level alarm, so that if an emergency happens, you actually have that working amount rather than being just above maybe the pump on point.
And this was a standard program that I was working with.
Yeah.
Awesome. Another question we have here is, how does Preferred provide BACnet addresses to their customers?
We do not provide them the addresses as far as, did they specify that, Michael?
No, they just said BACnet addresses, didn't specify it. Which ones?
Because we have standard BACnet points within our OITs, and what happens is they put their addresses in a special screen on our OITs so that they can communicate with that device over their system. So they're the ones that put the address in.
Okay. Alex, David, anything?
I mean, we design our controls to be very flexible in the field to set up communications. So sometimes it's just a matter of letting somebody know where the menu is. But yeah, it's very straightforward in most cases to set up BACnet or Modbus communication in the field. Changing addresses, BACnet IP, if they need to change the address, it's very easy to do.
Great. Just a couple more questions here. We're about an hour, so let's just try to get to these few. It says, this is more of an in-depth question. It sounds like he's talking about a specific job. It says, we have a school with an existing number 4 fuel oil boilers with underground tanks and sidewalk. The boiler replacement project replaces boilers with a new number 2 oil and fuel oil systems while keeping the existing underground tanks. Any potential issues to look out for?
Well, I would.
Number one, they should make sure they clean the tank out.
That's exactly what I was going to say. Yeah. I saw a job where we couldn't figure out why the pumps were cavitating really high suction pressure until we pulled the dip tube out of the existing tank. They're running number 2, but they previously were running heavy fuel, and the foot valve was completely encrusted with heavy fuel. So yeah, checking in the tank, making sure that's all clean. As far as
clean all the lines out.
As far as number 4 fuel handling equipment, I've seen several systems that they've run lighter fuels in it, and it hasn't really seemed to be an issue. Is that your experience as far as the pumps and things like that?
Not so much 4 oil, because basically 4 oil is just a mixture of 2 oil and 6 oil. Right. But you still have the possibility, because 6 oil is a great place to hide a lot of crud. So, and if it's not heated up constantly, you got a lot of solids that are settling and stuff. So you do, like you said, you saw the encrusted material around the bottom of the foot valve. So the thing I'm trying to say is, it would behoove them to make sure that the transfer system and the storage facility is clean before they start, so they have no chance of any problems in the future.
Yeah, I would say another thing, generally speaking, the strainer baskets on a heavy fuel system are going to be pretty large, like 1/64th perforation. On a diesel system, you might want to drop those down to like a mesh, just for the protection of the transfer pumps. That might be something to look at as well.
Excellent idea.
Great. Just looks like 2 more questions here. It says, following up with the node A and B, so we had the question about the node net A and B with our FSC system. If the node A and node B run in the same conduit or run together, and a forklift breaks the line at the same time, well, because of that, let's say if we're saying because of this, do you run the node A and node B separately?
It all depends on the requirements of the facility. I mean, if we're talking, this is backup fuel for a boiler at a middle school, okay, it's not really that big of a deal. But if we're talking a hospital or a data center, yeah, I mean, if they're looking at redundant fuel systems, N+1 on a lot of different things, yeah, we'll definitely consider running those separately. So, get a little bit of redundancy on the communication. And in fact, it's something that with a traditional system is nearly impossible to do. It's nearly impossible to have redundant field wiring from, say, day tank level sensors with a traditional wiring setup. So that's one of the advantages of this. And I'll say another big advantage that we didn't necessarily anticipate so much is if you have an existing fuel system and you're trying to update the controls, it can be hard to decide, okay, do we pull the old system down and we're just completely offline until we hook up the new system? That can take a very long time, especially if you're in, say, a hospital that's running, that's occupied. Or do we try to run an entire new set of wiring for all the new controls and accessories and devices, in parallel to the existing? Well, there may not be space for that, and it's extremely expensive. So having this system where you can now run a couple of communication lines up however many stories you need to the day tanks from the main tank and pump set area, it allows you to get the new controls up and running and tested before swapping over from the old system. That is a huge impact, because as much as we do new systems and new installations, most hospitals are already in existence. They're already been built, and they're on aging systems that need to be retrofitted. So that's another advantage of doing it via communications.
Yeah, and I mean, I'm not sure if it was, I know it's talked about in the webinar, but that pump, that FSC system could still be run. It just wouldn't be able to be run from the central controller, correct, Alex?
Yeah, it depends on where the break is, right? So communication will still happen within that loop, but it depends on between which the break happens. So there is a possibility for partial operation between sections.
Great. And as far as last question I see here is preferred view IO is an optional or standard on preferred systems. So this is a system where you can look at your voltages and your amperages, I believe, Alex.
Yeah, that's standard on everything. So you're going to see for all of our on-off discrete on an FSC, you're going to see a little box that'll be red or light gray. You're going to get your milliamps for our analogs, and that's every system that has a touchscreen. Our standard is a 4-inch touchscreen. For larger systems, we'll often do a 10-inch touchscreen or have it go back to a command center, so you can see full system overview, which is very helpful. But yeah, even our standard automatic duplex pump set is going to have a 4-inch touchscreen and have that view IO.
Great.
Yeah, and Alex, I would add to that view IO screen in a multi-node system, you can see all the nodes on the system. There's a menu in the corner of that screen where you put in the node that you want to look at, and you might be on node 0 at the main transfer pump set, and you want to see what's going on at the day tank. If that's node 5, just switch that screen to node 5, and you can see everything on that day tank controller as if you were standing right in front of it instead of the other controller. So it's very handy for troubleshooting, especially large systems.
Absolutely. I mean, not only does it mean you don't have to necessarily take your meter out for the panel you're in front of, but you're not relying on secondhand information from a panel that's in another part of the building. Yeah, that's huge for troubleshooting, and I use that a lot.
And I work in Texas, so I will usually position myself at the node that's inside in the air conditioning and view the others remotely.
Of course.
Yeah, here in New England, consider that as well in cold weather.
David, do you have any other questions you received or for the webinar?
I didn't get any questions, but one thing I would like to add, from years of field experience is these European style terminal blocks that everybody switched over to about 15, 20 years ago, they loosen up on the truck. And you can get intermittent contact in a terminal block that can drive you crazy. Because the wire will be making most of the time, and then just due to a little bit of vibration or something, the wire won't make for a second, and send you into alarm or trip you, depending on what the wire is used for. So before I get too far in a startup, I take out my screwdriver and just tighten down every terminal block nice and tight. Otherwise, you can chase your tail for a long time looking for a loose wire in a terminal. And
From a
give one
field
pull test.
standpoint, my field that's a standard for doing a startup and even service is to check all the terminations and make sure they're snug, because who knows what happens.
Right, and with these European style terminal blocks, you can stick the wire in, you can tighten it down, and it'll look like it's in the cage, but it's not. And you give it a pull test and the wire comes right out. So every wire should get a pull test after you've tightened it down.
Absolutely.
All right. So if we don't have any other comments, I do see one just asks if the view IO can be logged and trended, I guess. Alex or David.
David, do we have the capability to do that with our cloud monitoring software?
The cloud platform can monitor everything that has a Modbus address in the OIT. So if you can see it on the screen, it has a Modbus address because that's how the OIT communicates to the FSC controller. So I think the answer to that is yes.
And if you don't have the cloud monitoring software, our alarms, it's not the same as the View IO screen. It's not every single status, but we do have our history for alarms is great. We have in black text, we have statuses. And then for any alarms, when they come in, it's in red text. And then we also have a time and date stamp in green when it clears. So it really gives you a lot of historical information and data there. So if somebody, you know, on the midnight shift there decides to cancel an alarm 11 times, you're going to see all of that. So it doesn't necessarily record and trend all of the View IO, but we do give you a lot of historical information.
Great. I really appreciate the feedback on that, Alex. All right, if that's all the questions for today, I just want to let everyone know once again, this recording in its entirety will be up on the YouTube page, on the Preferred Utilities YouTube page, and then also on our website under resources and webinars. So you can view for your viewing pleasure. You can binge all of our other fuel oil webinars, combustion webinars. Feel free to just pop those on Friday night and just watch all those.
What do we have coming up, Michael?
Coming up next, we do have a combustion webinar. We're going to be talking about a little bit about some of the parts of the boiler room. David Oaf will be presenting that one. He's the other engineer on the line, and that is in 2 weeks. So that will be on the 25th of June. So a combustion webinar on the 25th of June. And any closing comments, Alex, David, and Don?
Well, I would just say, I know a lot of people that I run into know us for fuel oil, and maybe some on this webinar right now. David, would you want to give just a quick teaser about what we do for boilers and what's coming up?
Well, we did a webinar a little while ago that centered on how we do control systems for mission critical fuel systems. This is going to be kind of a parallel for boiler systems, and how NFPA boiler code is very strict about how you run boilers, but it's also the very minimum standard for safety. And we do quite a bit of stuff that goes above and beyond NFPA code because we've had near misses, or we've heard of failures, and we figured out a way to fix them. So that's primarily what we're going to cover in 2 weeks.
Nice.
Great.
And we're not, this is something that I know some of the people that are more familiar with us on fuel oil. We've been doing combustion controls for quite a while, David.
I think since the early 1970s.
Right. Great. Well, I'm looking forward to it.
Great. All right. I really appreciate Alex, David, and Don being able to be here. Really, really appreciate it. Thank you all for coming. I look forward to seeing you guys next time. And if you have any questions, you can email Alex, which is emails up there. You can email me, which will be on the email you'll receive after this with the full recording. Or you can email David Oaf, which is his email's not up there, but if you have a question for him, I can definitely get it out to him. And thank you very much, everyone, for coming, and we look forward to seeing you guys next time. Thank you.